Alright, so in this video I'm going to introduce natural numbers, absolute values, define what arithmetic is, exponents, talk a little bit about precedence, talk about integers, integer arithmetic, and fractions. Alright, so hopefully this is all review to you. Alright, so natural numbers, that refers to numbers 0, 1, 2, 3, 4, 5, etc., etc. And these are also called counting numbers, also called whole numbers. Sometimes people define these types of numbers with the 0, sometimes without. Alright, defining it with the 0 is common, and that's what the definition I'll be using in this class. Now, we don't have a different symbol for every number, every quantity, and numbers represent quantities in arithmetic. Okay, so if I was to keep going with this set, that would be, there's 10 symbols for 10 different quantities, and that's actually all the symbols that we have. But hopefully you know that there's this convention that we can recycle these symbols to represent other quantities. Alright, so for example, 1 with a 0, that represents the next quantity after 9, the number 10. Alright, and then a number like 234. The position of the number, the position of the digit, and each of these 10 symbols is called a digit. Digit also means your fingers. The reason they're related to, associated with your fingers, is because there's 10 symbols, 10 quantities. All right. So the first in the 234. Let me go back to that right now. Okay. So put an arrow to the 4. So the 4 represents 4 quantities: 4 iPhones, 4 Incredible Hulks, 4 of anything, 4 staplers. Okay. The next number, the second number starting from the left, that represents how many packets of 10 that you have. So in this case, that represents that you have 3 groups of 10 paper clips. Okay, so that would mean that actually represents 30 paper clips then, right? The next one the third number starting from the right represents a certain quantity, packets of 100. So this one means you have two Ziploc bags, each with 100 sunflower seeds. Okay, so that too tells you that you have 200 sunflower seeds. Okay, you put it all together, you've got 200 and 30 and 4, all together makes the quantity 234. Okay, now in addition to these type of numbers, natural numbers, we can also talk about negative numbers. Okay, -1, -2, -3, -4. And in a minute I'm going to talk about the absolute value and the distance of a number from 0. Okay, so in order to understand negative numbers really well and absolute values and distance, what I'm going to do is I'm going to introduce something hopefully you've seen before called a number line. Okay, so imagine that I took all the natural numbers and I wrote them one after the other, equally spaced on a line. Okay, and I'll put an arrowhead there to signify that I should keep going, but so just imagine I kept going 7, 8, 9 indefinitely. Okay, and then on the other side I'll put the negative numbers starting from 0 moving to the left. So -1, -2, -3, -4, -5, -6, and once again I'll put an arrow to denote that I intend you to think of it as if I continued it indefinitely to the left. Alright, so this is called a number line. Now, why is this useful? Well, first of all, thinking of numbers as in terms of pictures. Some people think really good with pictures. Our brains just are naturally wired to work well with pictures. So that's one reason to think about and use the number line. Another reason is absolute value. It might not seem necessary now, but later when you do more advanced absolute value problems, this is going to be a lifesaver. Okay, so the absolute value of 3 is equal to 3. The absolute value of negative 2 is equal to 2. One way to think about absolute value is whatever number you have, you simply make it positive. Okay, you simply remove the negative sign. So that's why the 3 was still 3, and the negative 2, I removed the negative sign, and so it became a 2. Okay, and I denote absolute value bars by absolute value operation by these 2 bars, almost like I'm putting the number in jail or something. Okay, and so you can think of it as removing the negative sign if there is one. Let me invite you to think of the absolute value as in another way. Okay, think of it as the distance to the 0. Okay, 0 is also sometimes called the origin. So let's go back to the 3. So I'm going to put a dot at the 3, an orange dot. Okay, so the 3, if I was to measure how many hops do I have to go to the 0, okay, so I have to do 1 hop, 2 hop, 3 hops, okay, and the number of these ticks, these hops, we'll call that the distance between 2 numbers. Okay, so the 3 is 3 away from 0. That's why the absolute value is 3. That's an equivalent way to think about it. Okay, that really turns out to be more useful thinking about negatives. So let's say we are sitting on the negative 2. So I'll put a green dot there. All right, how many hops is it to the 0, the origin? Remember, that's another name for 0. How many hops is it for that one now? Well, 1, 2. Okay, that's another explanation of why the absolute value of negative 2 is 2. All right. Okay, so now everything I've done so far has been in terms of quantities. In fact, you may have heard the word arithmetic. Okay, maybe you had a book called Arithmetic before you took this class, Algebra 1. Arithmetic means the study of quantity. So let's just get that basic definition here. Arithmetic, the study of quantity. Okay, if you have 3 camels and you add another one, how many do you have now? That's a question in arithmetic. If you have 4 pizza slices, and you eat 2 of them, now how many do you have? Okay, that is a question for arithmetic. Okay, now what is algebra? Okay, algebra is a big subject. In this class, what we're going to learn in Algebra 1 is we're going to learn tools, a little bit fancier tools to help us with arithmetic problems, with problems dealing with quantity. All right? All right, so let me now review integer arithmetic. What happens when you have negative and positive quantities and 0 and we start adding and subtracting? Okay, so you probably are comfortable with adding 2 positive numbers, and by the way, positive means it's on the right side of the 0 on the number line. It doesn't have a negative symbol in front. Okay, so something like 3 plus 4 is 7. Okay, actually, let me do a smaller number. Let me do 3 plus 2. And 3 plus 2 is 5. I want you to think about adding 2 in a new, well, maybe a new way for you. Okay? When I say that I'm adding a positive number, what I'm going to do, what that means is that I'm taking 2 hops to the right. Okay, you see that? So because I landed on the 5, that's why the answer is 5. Okay? What about if I was adding a negative number? What does that mean? Okay, so whenever I add a negative number, I want you to think about that I'm moving not to the right, but I'm taking a certain number of quantity of hops to the left. Okay, so adding a -4 means I'm going to take 4 hops to the left. So 1, 2, 3, 4. And where did I end up? I ended up on the -1 number line. Excuse me, the -1 position. So that's why the answer to 3 plus -4 is -1. Can you see how the number line and thinking about hops to the right or left really clears up if you've had trouble with negatives and adding and subtracting negatives? Okay, so that's addition. Let's talk about subtraction. So what if I had something like 3 minus 4? Okay, now you can, if you understood addition with positive and negatives, you can just think of subtraction as just another type of addition. And in fact, think of it as there's an addition problem hidden in there. So if you minus 4, that's the same as adding -4. Okay, so what that all boils down to is when you do 3 minus 4, you're going to end up moving 4 hops to the left, as if I was adding a -4. Okay, what about if I did probably the weirdest, hardest one, 3 minus 5? Okay, so how are we going to interpret that one? All right, so the -5 tells us that we take 5 hops. Well, if we added -5, okay, in fact, let me stick with, since I've been doing a lot of them with 4s, let me just make it 4 instead. Since we've done other examples with -4 and 4. All right, so if I was adding -4, we already saw an example where I had to move to the left, right? However, for the 3 minus 4 example above, didn't I say that one was similar to adding a number? Okay, so think of it as the two negative, one of them switches direction to the left, but then the other one switches direction again. So really, you're taking 4 hops to the right. Okay, so this is the same as 3 plus 4, which gives us 7. All right. So whenever you have two negatives, you can think that they blow each other up, and you just have a single positive left over. Okay. Let me show you yet another way you could interpret that. Okay, you can think of, I'll put it in the upper left. You can think of the minus as a negation. Okay, what does the negation do? A negation changes the sign. It flips the sign of a number. Okay, so if I had a positive 2, if I put this in front, I'm negating a positive 2, so now it's a negative 2. Okay, now that's all to say, what if I had a negation of a number that's already been negated? Okay, so what this means is, so one of them switches the sign, so the inside the parenthesis, you switch the sign of a 2 to a negative 2, and then the other negation switches it again. So that means now you have a positive 2. Okay, so this is just another way to see how two negations, two negatives blow each other up, you might say, and you end up with a positive. All right, so again, think of the number line and think about addition and subtraction as moving to the right or left. All right, so if that all made sense, let me erase what I have at the bottom and give you some other examples, and I want you to do these this time. All right, what about minus 4 plus 7? What about minus 4 minus 7? What about minus 4 minus negative 7? And plus negative 7, excuse me, and minus 4 minus negative Actually, instead of negatives, let me switch them all to not to 2. All the 7s to the 2s. All right, can you do all of these without making a mistake? All right, so I will work these out now. So the first number, in this case, for each one, the first number is a -4. So I am going to put a yellow dot at the -4, and then I'm just simply going to hop in whatever direction I need to. Okay, so for the first one, -4 plus 2, I take 2 hops to the right, and so I end up at the -2, so that's the answer to that one. On the one below that, I take 2 hops to the left, and I end up at the -6, so that's the answer to that one. Okay, the -4 plus -2, that's like the -4 -2. So I take -4, I take 2 hops to the left, so -6. And then on the -4 minus -2, the 2 negatives blow themselves up. And so at the end of the day, you're moving 2 hops to the right. So just like the first one, the answer is -2. Okay? All right, very good. So that's all I want to say about negation and integers and integer arithmetic. Now let me close by talking about fractions. So what is a fraction? So hopefully you remember that if I have something like this, 3/5, what that means is so far we've talked about whole quantities, right? Like 3 pizzas, 3 sheep, 3 staplers, 5 goats. Okay, when I have a fraction, I'm talking about a portion of a quantity, a portion of a pizza, right? People don't always eat an entire pizza. What do? You can eat a quarter of a pizza, maybe half the pizza if you're really hungry. Okay, so sometimes we need numbers to denote portions of entire quantities. All right. Now, the bottom number, when you write a fraction like this, what it does is it represents a certain size portion. Okay, imagine a pizza, and for this example, imagine that I split the pizza up into 5 pieces. All right, and so if you have 5 pieces equal in size, okay, that's what the bottom number represents. You're taking an entire quantity and you're chopping it up into 5 equal pieces. Okay, now, so I'll number them 1, 2, 3, 4, 5. Now the top number tells you how much of those little portions you have. All right, so 3/5 means you have 3 of these pieces that are the size you get when you chop it into 5 pieces. Okay, so that gives you this. I'll shade the green. That's how much of the pizza you have. All right. That's how I want you to think about fractions. All right, and pizzas are a great image to think about it. Okay, now we can add fractions. All right, imagine if I had 3 of those portions, and then maybe I added another one. Okay, so if I have 3 of those pieces and I add another one, then I just add here. I'll add more green area. I'll add that. Okay, so now I have 4 of those same size pieces. So that's how you do fraction addition. Okay, if the bottom number is the same, you simply add the tops. Like in this case, 3 plus 1, and keep the bottom the same. All right, and then you can also do subtraction in a similar manner. Think of it in a similar manner. So this time, let's say I had 3. Let's go back to 3 pizza slices. All right, and now I ate 2 of them. Okay, so I had the green area. That's how much pizza was mine, and then I ate 2 of those pieces. So I'll remove the green from 2. So clearly I only have 1 of those sized pieces left. So that's how you do fractional subtraction. Okay. So in summary, if the bottom numbers are the same, you simply do subtraction with the top numbers. In this case, 3 minus 2. Okay. What about if the bottom numbers are not the same? Okay, that gets a little trickier. What we need to do, in short, is you need to make them to be the same. Okay. Let me show you what I mean by that. So in the upper right, if I have, let's say, 3/5 plus a 10th, how in the world do we do that one? Okay. Well, you saw that I was able to split the pizza into 5 pieces, and you saw I shaded how much I had when I had 3 of those sized pieces, right? Now imagine that I cut the pizza into twice as many pieces, so 10 pieces. So this is 5, but now I'm gonna chop each of those little pieces in half. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you should be able to see that if I have 6 pieces that are half as big, that 6 of these tinier pieces is the same as 3 of the bigger pieces. Okay? So let that be your guide to understand how you can change a fraction to another. You can change it to an equivalent one with a certain number, different number on bottom. Okay? So 3/5 is the same as 6 of the other on the second pizza. So this, I'm going to write this as, this is 6 over 6, this equal quantity, this similar equivalent fraction, plus 1/10. Okay, so then the answer is 7/10. All right. So in short, if the bottoms are different, you need to change one or both fractions. You need to change fractions until you've got a situation where they are both the same. All right. And then once they're both the same, then clearly subtraction works the same way. All right. And now let me show you how to do multiplication and division. Okay, so if you have a fraction multiplied by another fraction, you hopefully remember that what you do is you multiply the tops and multiply the bottoms. So in this case, 3 times 1 and 5 times 2. All right, that will get you the right answer. All right, now if you have division of fractions, hopefully you remember that you can remember how I converted subtraction. I was able to convert between subtraction and addition. Okay, so likewise you can convert between multiplication and division. What you have to do is do what's called the reciprocal, or the inverse of the second number. So the last one, the bottom one, becomes this multiplication. You see how I flipped the numbers, the 1 and the 2? Okay, and then once you do that, you can simply do multiplication, and so that's what you get for that answer.